This is Geometry Unit 9, Day 4 homework from Section 5.1, page 298. We're looking at placing figures in standard position. We have a right triangle. We have side lengths of 3 and 2. So if the side length is 2 and then 3, we have a right angle at the origin. So we'd be 0, 0, 3, 0 for our coordinate along the x-axis, and 0, 2. You got to put the 0 first. 0, 2. It is possible you would have them reversed and put the 3 on the y and the 2 on the x. It wasn't real specific which way it had to be. For number 13, we're supposed to have an isosceles right triangle. Isosceles means two legs are going to be the same length. So we'll come up 7. And over 7. The right angle is going to be at the origin, which is 0, 0. We're 7 to the right, and we're 7 up. An isosceles right triangle. We're going to do a square with the side lengths of 3. So we have our coordinate at 0, 0. We're 3 to the right. We're 3 up. And of course, this fourth point is 3 to the right and 3 up. For number 15, we're going to do a scalene triangle. One of the sides is going to be considered 2m. So with this one, with it 2m, we wouldn't need graph paper. Graph paper would have been handy for 2, 3, and 4, but now since we're using letters, graph paper would not be handy. So 2m, we of course are going to start at 0, 0. In standard position, you need a point at the origin. You need a point along the x-axis. Let's call that 2m, comma 0. And then for a scalene triangle, there's many different ways you could draw this. The 3 sides all have to be different. So I'm going to come over a different amount, and I'm going to come up another different amount. So we can call this H and K if we want. R and S, A and B, any 2 letters you desire. They're not related to the 2m. For number 16, we're going to do a rectangle. The length is A and the width is B. So let's call length this direction and the width this direction. Just because width typically means left to right, I'll do width with the B. And length, I guess that'll be the amount up. So our fourth point now is going to be over B and up A. But if you put your coordinates in the opposite direction, then yours would also be A, comma B. So there's nothing that forces length or width to be a certain direction. For number 17, we're going to do a square. and the side length is going to be S. So I know this is going to be S comma 0, 0 comma S, and our final point will be S, S. For number 18, we're going to have an isosceles right triangle, a leg length of P. So an isosceles right triangle, isosceles meaning two sides are going to be exactly the same, right angle, so the distance along here is going to be P comma 0 and 0 comma P, and then this would be 0 comma 0. A right angle, let's put the right angle at the origin, and this would give us our isosceles right triangle. For number 19, we're going to have a right triangle, leg lengths R and S. So alphabetically, R comes first. So we'll call this R comma 0, so that's a length of R from 0, 0. And then S in the alphabet comes later. So we'll call the longer side something different, which is S. For number 20, we're supposed to do the distance formula here. So the distance formula is going to be R1 minus R2, X1 minus X2 plus Y1 minus Y2. So that's going to give us R squared and negative S squared, which comes out to be R squared plus S squared. You can't do anything more with that because of the plus. You cannot simplify that. Then they ask us to change the coordinates here a little bit. Place the triangle another way and use the new coordinates to find the length. So another way might be maybe S this way and R up, or let's see if that would be different. If we did R this way and S up. So this is still R comma 0, and this is still R comma S. So for us to do our calculations of the distance of the hypotenuse, we're going to use the endpoints of the hypotenuse. So again, you would use x1 minus x2 plus the y subtracted. That's going to leave us with r squared and positive s squared. And that's our final answer, and that's the same. So as long as they're listed accurately, you should be getting the same answer regardless of the way you listed them. You just need to be sure you follow the directions correctly. This is number 30. A rectangle with side lengths of 3h and K has a vertex at negative h comma k. So it has side lengths of 3h and k. If we have a vertex at 1h, negative 1, negative h, up k, okay, one way we could draw this is to say that we come straight down which is at, this guy here would be negative h comma 0, and then go over 1h, 2h, 3 h's, which would be 2 more h's. So we want to see 2h comma 0. Okay, that's possible. So that rules out option C. So option A is h comma k. Option B is negative h comma 0. Option C, 2h comma 0. And option D, 2h comma k. So we've already ruled out that we can have this one happen and we can have that one happen. So this was at negative h comma k, and those are your 3 points. So hk would be here, h comma k. So if that was it, that's just 2 units. We don't have 2 units in any direction, so I'm thinking that that can't happen. 2h comma k, I believe that could happen. If we have this point at negative h comma k, could we go to the side 2 more h's and up k? And then that would be like this side. We could go like that. We could also go this way. We just need a vertex here. So we can rule that one out. So point HK could not be a vertex. In this situation. So that was option A.